Nah, you won't.
That's it. So welcome, everyone. Welcome to GCP Next 2016. I'm Prajakta, product manager in the cloud networking team at Google, in the Google Cloud platform. So let's start with you today. You just sold your CIO on the idea of moving your workloads to the Google Cloud. Congratulations. Yeah, you started first with saying, yeah, we have on-demand access to compute. You're going to save tons of money. But what really clinched the deal for you was this: Google Cloud Platform's world-class infrastructure and Google Cloud Platform's best-of-the-breed cloud services. That is why Google Cloud Platform gives you the ability to deliver your services anywhere, anytime, across the globe. So how does Google Cloud Platform deliver your services reliably, right? Across the globe, with high performance and with low latency. A key cloud service that lets it do this is Google Global Load Balancing, and that is the focus of my talk today. I'm sure all of you are familiar with load balancers, but maybe let's do a load balancer 101. Now, load balancers were created to deliver high availability and to scale the services. And if you look at a load balancer, as you can see there, you have your backends. These are the ones that actually service your clients. You stick a load balancer in front, you put a front-end whip on it, and voila, you have a service where the load is distributed across all of these servers. You have a service that's resilient, because if one of these fails, your load balancer will seamlessly route the request to another healthy instance. You can scale your service now, because you simply stick another server there and it scales up. And lastly, a load balancer is the one that hosts your front-end whip. So one more thing that I talked about in the previous one, right? It's load balancing 101. Now let's look at it from the point of view of a cloud provider, right? Look at the cloud. You have a multi-tenant environment. You have thousands of users. You have compute resources that are scattered across the world. And then you need the ability to seamlessly scale as the number of your users and the traffic grows. So you look here. You see 3 or 4 flavors of load balancing, right? The first one is your hardware load balancers. Think of them. I'm sure all of you have used them. They have fixed form factor. So if you need more throughput, what do? You go and buy a bigger box. If you need more features, what do? You approach the vendor and you wait for their release to put the features in. HA is pretty much active-active or active standby. And these are definitely expensive to load balance at scale, especially cloud scale. Next come the software load balancers. And when I talk of software load balancers, I mean load balancing logic that runs in a VM, instance, could be a cluster, right? Now, these are definitely a step up. But is that enough to deliver cloud scale load balancing? That is where the Google Cloud Platform Global Load Balancing comes in. It's basically software-defined, globally distributed load balancing, right? That is exactly what Google Global Load Balancing is. And today, I wanted to shed some light on it. So some interesting aspects about it that I wanted to highlight. So first, let's start with you again. Why do you want global application delivery? Maybe you want to deliver your services around the globe. Maybe you need the highest levels of availability, so you want to replicate your services around the globe. Or you want to deliver your services with low latency, close to wherever your users are. That is what Google Global Load Balancing enables you to do. Instantiate your workloads anywhere you want in the globe, but unlike traditional DNS-based load balancing solutions, you don't have to front-end each region with its own IP. You can front-end them with a single IP. Finally, you can deliver low latency and high bandwidth connectivity for all your users. And with all of this, you can think of Google Global Load Balancing as having infinite capacity. So as your users and your traffic increase, it just seamlessly scales. Now let's take maybe a sneak peek at what's inside, right? Because often I get asked, where is the Google Global Load Balancer? The answer is it's everywhere. It's not a single box. It's not running in a VM. It's not a cluster. It's load balancing distributed across the world. And there are 4 key technologies that make this happen. 1, software-defined load balancing. 2, Google's global network. 3, seamless autoscaling. and fourth is intelligent Anycast. So how many of you have not heard of software-defined networking? Raise your hand. OK, that's great. So basically, this is software-defined load balancing, which builds on the concepts of software-defined networking. Now let's look at the right. As you can see there, that is what the Google Global Load Balancer does. If you look at the traditional load balancer, you see a single load balancer, right? If you look on the right, which is the Google side of things, there is no load balancer. And the reason for that is load balancing is done by distributed software-defined entities called Google front ends. We call them GFEs very lovingly. And the GFEs themselves are distributed across the world. And they work in conjunction with a number of other software-defined systems to do global load balancing. Now, what they really enable you to do, as you can see, they're at the edge of the Google network, and you can see a number of GFEs. So when somebody says, where is the load balancing? It's in each of these GFEs, which are scattered around the world. The GFEs enable you to terminate your user traffic closest to your user, and they load balance the user request to the closest healthy backend with available capacity. So they do work with other software-defined systems to do very sophisticated load balancing, which is a function of proximity and capacity, so available capacity, essentially. Now let's look at the second key enabler. That's Google's global network. Google has 70+ edge POPs across 33 countries, and it has a high-quality private network for edge to data center connectivity. So each of these are connected to the data center, and you're computing the data centers through this very, very high-quality network. Now, out of these 70 edge POPs, these load balancing GFEs are placed in 50 of these POPs, close to your users across the globe. So again, as I said before, if anybody asks you, where is the GCP Global Load Balancer? The answer is, it's at all of these 50+ POPs across the globe. Now let's look at these two diagrams a little bit closely, right? Because your next question should be, sure, you let me put this close to the user. What's the benefit for me? Look at the left. That's your traditional cloud provider. Your user's request is going to traverse just the general internet for a majority of time and finally reach the load balancer in your cloud provider's data center. Now let's look at the Google Global Cloud Load Balancing, right? If you notice, the GFEs are sitting very close to your user. So the first line, which is your TCP session 1, your user request is barely traversing the internet, right? And this means because it traverses the internet for a short time, beyond that, the GFEs will make sure that they deliver your request over Google's high-quality private network. And what does this do for you? The benefits are significant. Reduced latency and improved throughput for your users. Delivering unflappable services even in the wake of stability or instability. And one thing which is not obvious, but which I wanted to point out, serving static cacheable contents from multiple points near your users. So why doesn't everybody do this? This way of load balancing is not easy to architect. It needs a global network, and it needs sophisticated software and distributed technologies. And Google has been doing this for the last 15 years, and that's what we are really leveraging for Google Cloud Load Balancing. So let's come to the third part. A question we often get asked, how many VMs should I provision for my service? For that, the first thing you should do is look at your workload. Maybe your business is growing fast, so you need to scale up steadily. Or maybe you have bursty traffic. Or maybe your traffic is on and off in nature. Maybe you're running batch workloads. Then you come to the classic resource allocation problem. If you provision for peak, you're wasting resources. If you provision for average, you're in big trouble, right? So the ideal way is to provision in line with your traffic. And this is where Google Cloud Platform Autoscaling comes in. It intelligently adjusts resources based on load. So if your traffic grows, so do your resources. If your traffic shrinks, your resources shrink as well. But most importantly, to do this well, this auto-scaling does this scale up in a matter of seconds. There is no pre-warming needed. So if there was one takeaway about auto-scaling, I want you to take that away with you. Now, how do you provision autoscaling? So basically, you provision autoscale instance groups, and you specify an autoscaling policy. It's a very intuitive, intent-based policy. You say stuff like, OK, keep my VMs at 85% utilization. Now, autoscaler, it will monitor your instances. It will work closely with the global load balancer, and it makes sure that if the capacity of your VMs goes below the configured threshold, it will scale them up in a matter of seconds. The last key technology I wanted to talk about is intelligent Anycast. Now, let's look at this technology through the lens of an actual deployment. Let's say you decided to host www.myapp.com on the Google Cloud. Your users are all over the world. So you put your compute instances in 3 regions. Let's say you put them in US central Google data centers, in Europe, and then in Asia. Now, normally with any other cloud provider, you would have had 3 DNS whips, 1 per region. And then you would have to use DNS load balancing to sort of send them to the correct region. If you've used DNS-based load balancers before, so like global server load balancers, I can say that confidently because I wrote code for a lot of them. You have a bunch of issues that you have to deal with. First of all, DNS-based load balancers take minutes, if not hours, to detect and react to change. They also suffer from resolver caching and other well-known TTL-based issues. Now, if you look at it in contrast, let's look at the intelligent Anycast. You have a single IP, so there is no problem with caching. Wherever you go, it's the same IP. What that means is Maya in California, Bob in London, and then Shen in Singapore. They each use 120.111 to reach your service, myapp.com. Intelligent Anycast also directs them to the resource that's closest to them with available capacity. And there are a lot of things that I have not put here. But for instance, if they are routing flaps, it will ensure that your request goes to the correct place, the place that can serve it reliability and can serve it well. So your next question will be, yes, this sounds great. How do I get started? Just go to the Google Cloud Platform website and get started configuring it. Select the flavor of your load balancer, so whether you want HTTPS load balancing in this case. Select and deploy your backends, configure a front-end Anycast whip, and you're done. I don't know if you can see things clearly, but what I wanted to show is a new UI that's making its debut next month. It's as simple as just picking the first option, start configuring, and then you go configuring the 3 steps that we put there. I purposely didn't show you the other 2 because I want to highly encourage you to go and try them out yourself. So honestly, the biggest benefit or the biggest advantage that Google Cloud Load Balancing delivers is peace of mind. You can see the quote on the screen, right? That is one happy customer on the screen, and there are many more who would say the same. So I highly encourage you to try it, and I'm sure it will give you the same peace of mind as well. One last interesting thing I wanted to point out is that Google Global Load Balancing not only delivers your cloud services, but it's just as essential to Google's own services. It uses the same set of software-defined technologies and the same global infrastructure that are being used to deliver Google Search, Gmail, and other Google services. So definitely use this information when you're trying to clinch getting your CIO to move the workloads to the cloud. So with that, it's time to see global load balancing in action. Please welcome our next speaker, Anna, tech lead for global load balancing, to show you how to deliver reliable services, not just at cloud scale, but at North Pole scale. Thank you. Hey, Anna.
Thank you, Prajakta. Today, we will be looking beyond cloud scale availability. All cloud providers publish the SLA. Some publish 3 nines, some publish 3.5 nines like GCP. But what if you want to build an application that has 5.9 availabilities, or even beyond that? That's how Google builds its applications. There is a short answer for that. Use global load balancing. With global load balancing, you get worldwide capacity anytime anything happens. You get a protection against region-wide failures. And with cross-regional overflow and cross-regional failover, you're getting highly available solution. Today, we're going to be walking through the example of highly available, globally load balanced service, Santa Tracker. Who doesn't like Santa? Whether you're a child, an adult, or in between, it's always fun to watch Santa to deliver presents. And while Santa is busy delivering presents around the world, you and I, as a service owners, will pay attention to traffic volume and shape and get to experience a series of disasters that typically happen over service lifetime. We'll start with configuring Santa Tracker service on GCP, with configuring it in 3 continents. Why? Because service is global and Santa going to be traveling around the world. We'll create 1 instance group in Asia, 1 in Europe, and 2 in United States to account for anticipated traffic. Unfortunately, I was up all night prepping for all talk, and after playing with the manual added instances, I forgot to enable Autoscaler in Asia. So watch for it. It's going to bite us later on. As the day starts, Santa is hard at work delivering presents. And while children and adults watching him to drop presents through the chimneys, you and I looking at a console. And guess what? The traffic volume is a little higher than anticipated. In fact, it is a lot higher. So on one hand, we are happy that our service is so popular. On another hand, we don't know what's going to happen. Do we have enough capacity to serve? Are we prepared for success? And indeed, interest in Santa is not letting up. And now we have a lot of traffic incoming. And suddenly, we see overflow to Europe. What just happened? Well, what happened? We go back and look at our configuration and we figure out that we didn't have Autoscaler enabled. So our global load balancer saved us from the outage in overflow access of traffic to closest region without any intervention. So we go back, enable Autoscaler, and as Autoscaler is starting instances, health check, and they're ready to serve, the traffic is moving back to China, to Asia, serving locally with a minimal latency. As day goes by, now Santa is in Europe. Our instances in Europe just got new binary with support for Elvish language. Unfortunately, the feature wasn't tested well. So the first time elves, the Santa helpers, tried to test, check the status of Santa Tracker, the binary crashed. Don't panic, nothing happens. Our global load balancer immediately recognized the health of failed instances and moved traffic away. Let's stop here for a second and analyze what just happened. There are no other cloud provider that has cross-regional failovers. And let's see whether regional failover would work. And it wouldn't, because all binaries within a region are running the same version. So as long as elves continue to send query of death, the binary would continue to crash. Our global load balancer, on the other hand, proactively picks number of failover candidates without any configuration. All is done automatically. And based on the health, size, and remaining capacity, it constantly recomputes new failovers every 2 seconds. And you look at it and you see that lines are going a little bit far away. But what we say, that even though the traffic is moving in the US and temporarily you're getting a little bit higher latency, it's much better that not being able to serve in the US, right? Because that's what would happen should we stay in US, in Europe. So we rolled back the faulty binary, and now previously stable binary runs without Elvish, so poor elves would have to query in English. Next year, then. This is the second time when global load balancing saved us from full region outage. As the day goes by, Santa is traveling and delivers present now in America. With a single load balanced IP, our users experience best latency as users from each host come to the closest instance groups. And as they come to the close, and we think we're almost done, Rudolph the reindeer went on a famous talk show and endorsed the Santa, and it also said that why don't you go and check out our favorite Santa tracker. And sure enough, millions of people flock to our website, creating a perfect storm of locally generated traffic. We're holding our breath. What's just going to happen? Because there's so much traffic that even buffers that Autoscaler kept for extra capacity being overrun immediately. But our load balancer saves us, again, within seconds starting to move traffic where additional capacity is, starting from the closest, and then going further away if there is not enough capacity still. In the meantime, our Autoscaler grew back up, and the traffic caused by Rudolph is moved back to US and is now served locally. And as viewer attention moved on, so did the traffic, and now we are back to our regular serving. Global LB saved us yet again, this time from multi-region outage. After delivering presents in Hawaii, Santa is getting well-deserved rest. And we can look back at our long day and see what happened. Global load balancing helped us to successfully serve huge number of QPS and averted 3 potential disasters. In Asia, we had an error in configuration, which was mitigated by cross-region overflow and then pulling back when Autoscaler grew back up. We survived the crash of our European instances and mitigated it by temporarily rerouting traffic to United States. And in United States, we rolled out a perfect storm of locally generated traffic by moving traffic and dipping in worldwide in the capacity. Obviously, I didn't talk about all cases that could have happened. And so I encourage you to pick your favorite case and analyze it in the presence of global load balancer. I hope this example of running globally load balanced, highly available service persuaded you that global load balancer is the way to build scalable, reliable, and highly available global load balancing. Come and try HTTPS LB on GCP. And to further learn about best-in-class global load balancer, please welcome Matt Smart, Tech Lead and Manager at Google.
Thanks, Anna. So as Anna demonstrated, global load balancing is an important tool to improve reliability and availability and serve your users with low latency. To even further reduce latency for your users, you can use a content delivery network, or CDN. A CDN will cache your site's content all around the world, speeding delivery to your users, while also offloading work from your backends. To that end, the Google Cloud Platform has partnered with 6 CDN operators through our CDN Interconnect program. With CDN Interconnect, you'll get optimized connections to your CDN of choice and pay less for network egress. And in the coming weeks, we'll be launching the beta release of Google Cloud CDN. Google Cloud CDN is our own delivery network, and it integrates seamlessly with the global load balancer. We've deployed our global load balancing stack at more than 50 points of presence around the globe, as Prajakta mentioned earlier, and it integrates with Google Cloud CDN at each of those locations. With Google Cloud CDN, your cacheable content can be served directly to your users from each of those 50 locations. Not only do you get a world-class edge presence backed by the global network Prajakta mentioned, your cacheable content can be served directly to your you can partition your site based on the backend service to enable CDN for only those portions of your backend services that's highly cacheable. Leave off your admin APIs, but use it for your static content, your CSS, your JavaScript, maybe those Elvish and English language files, all without hosting it on a new domain. You can also analyze how well you're doing with cloud monitoring, which is stack driver integration, and cloud logging. So as we saw with Santa, you know you're going to have a lot of traffic, but you might not know how much. Why should you need to send test traffic or trickles of live traffic just to warm up your load balancers? When we created the network load balancer, which is a precursor to the global load balancing for TCP and UDP traffic, we wanted to take it for a spin. So we did what any normal Googler would do. We threw 1 million queries per second at it. So global load balancing, we wanted to do the same thing. In this case, we took it up to 1.3 million. And then we stopped because just we wanted to stop. And as you can see, this is to a single Anycast address, no DNS load balancing required, between regions. And all this traffic is being sunk at whatever regions the traffic is coming from. In this case, we both had the sink and the source in these 3 locations listed. Again, no pre-warming necessary. Up, over, down. With Google Cloud CDN and global load balancing, we decrease latency in a couple of ways. The first, again, is by having these locations all around the world physically close to your users. The second is by supporting modern protocols like HTTP2, which reuse the network very well and more efficiently. So let's look at how well we do. This first section, we've got your application deployed in a single region, in this case, US East 1. And the data is showing median load time for 100 kilobyte files. We're doing pretty well in New York. That's that little red bar. But the rest of the world is pretty grumpy. And we like the rest of the world. The second part, we've deployed our application in more regions. In this case, both US regions, Asia, and Europe. That's gotten much better. But the gold and the green, South America and Australia, they're still not quite that happy. And we want to do better. The third part, we've enabled Cloud CDN. I can't see what that says anymore. I think they're pretty happy now. So our users depend on Google Cloud Platform to deliver resilient, auto-scaled services with a global footprint. We've described how global load balancing fits into that picture, but you really don't have to take my word for it. Let's hear from a power user of Google Cloud Load Balancing. Please welcome Dmitry from Wix.
Thank you, Matt. Hi, I'm Dmitry. I'm solution architect at Wix.com. I want to tell you how we took and moved one of our services to Google Cloud. Sorry, it's going to be this one. So, what is Wix? For those of you who are not familiar with the company, it's easy. What you see is what you get service to building a website. So business owners, even non-technical ones, can easily build the site for the company the way they want to see it. And the platform is built up of many services, many products, and hundreds of services. But today, I only want to talk about one of them, which is image serving and manipulation. So the service itself is very simple and basic. It's exactly what it sounds like. Site owner uploads an image. Site visitors come and see it on the website. But we do not serve original images. We resize them, adjust them on the fly to improve user experience. So if you open the same website on a desktop and mobile device, you will get the same images in different dimensions. And the numbers you are seeing here are growing month after month, just like today's snapshot. So we have big storage to handle, many requests to serve. And today, I have to say, we'll run on active setup on both Google and Amazon. And I can tell you a lot about platform differences, subject to totally different talk. So let's start with some history first. 3 years ago, we were running in free on-prem data centers. This means storing each image 3 times. And the machines that were doing the image manipulation were keeping the images in the local storage. The downsides are quite obvious. With the growth we have, we had to double our capacity each 4 or 5 months. Without stopping the service, moving the files, not a nice task to do. Don't do it, please. Don't. And of course, there's the hardware. You have to keep your maintenance going. You have controllers failing. You have the hard disks failing. You have batteries. Just name it. Everything can go wrong. So we start moving to the cloud. And in the very beginning, it was not easy. Many features were missing. So we had to be very creative. So what we were doing at the very beginning, we were serving the traffic with a network load balancer through one single region. And we were manually creating our instances, adjusting the size of our setup. It means if we were expecting more traffic to hit, we were creating just enough instances to handle it. Now, Wix strongly believes in continuous integration and continuous delivery. With the hundreds of services we have a new version hitting GA every couple of minutes, OK? No one can predict which one of them might affect images traffic. No one. We had to be very responsive, not recommended, long nights. So when Autoscaler arrived, it just changed the way we live, changed the way we do anything. It removed this need to configure and tune things manually. We could sleep at night, finally. Autoscaler is a very critical part of the system. It was mentioned before, but put little thing in it. Like, if you have too many instances running, you just pay with extra money. Well, if you have not enough instances running, you pay with your system latency, you pay with your system availability, you pay with your customers. Okay? And Google Autoscaler keeps you with just right amount of instances, even in traffic peaks. And it adapts extremely fast. It took us time to put trust in Autoscaler. Today we know we can trust it, but it took us time. I will give you just one example that we had. There were auto-skilled instance group running with metrics below the threshold for a long time without any imaged instance being removed. Strange behavior. So we open a support case. We have a conversation with the team. What we realized is that Autoscaler took care of us. Removing even one single instance would raise the traffic hitting the remaining instances. That will raise the metric above the threshold. New instances would be created. So Autoscaler was smart enough to keep us from this flopping. It just kept us safe. Of course, also the health checks. When global HTTP load balancer came out, it finally allowed us to serve the traffic from multiple regions. We could stay up whatever happens in any single region. It was fantastic. Now we can control the traffic to hit specific instance groups, and the opposite, we can drain the traffic from the others. Of course, there are additional pieces in the puzzle. You have deployment manager. You have preemptible VMs. By the way, preemptible VMs are one of the reasons we prefer the traffic to hit specific instance groups. It's fantastic. It's all easily configurable, and it goes from 0 to full scale in a matter of seconds. I will give you just this small example of traffic. Small weekly traffic we have. You can see the traffic goes up and down as the day goes by, and can see the amount of instances adjust accordingly. Magic way, no hands involved, everything goes automatically. And you can see the response time stays the way it should be, stays the way we defined it. And the most exciting thing that I like, look at the bottom right graph. You see this traffic spread across 14 different instance groups in different zones of different regions. And you can easily see when traffic of some instance group falls down for any particular reason, like preemptible VMs were taken from us, or we deployed faulty version, it hands over automatically to other instance groups, and no harms to service happens. We stay up 100%. So if you haven't tried all this magic before, just do it. So let me handle you to Prajakta to summarize those things.
So hi, folks. I'm back. And the reason I'm back is, first of all, to thank Dmitry and Wix for being here with us. And whatever we say at the end of the day, if customers say that, it's probably much, much more powerful. So that's why I wanted you to hear from him personally. So thank you, Dmitry. The reason I'm here is because if you leave this room, and I'm hoping you do after we are done, but when you leave this room, you leave with 4 key takeaways. First, our global load balancing is software-defined load balancing for cloud scale. It uses state-of-the-art software-defined technologies and distributed systems technologies, along with, of course, Google's global network. The second one is you can deliver your services across the globe with a single Anycast front-end whip. You will not find this in any other cloud provider. Third, it will deliver high performance, low latency, and seamless scaling, or rather seamless auto-scaling for all your services. And lastly, you can optimize your delivery across the globe using 3 things: Cloud CDN, CDN Interconnect, and of course, Google's global network that enables all of this. So with that, I think we come to the end of it. Feel free to get any one of us if you have any further question. And with that, let's conclude and say, scale on. Thank you.